Okay, in this example, they want us to show that these 3 points are the vertices of a right triangle. Now, you basically have 2 choices with this. You either find the slope between the 3 coordinates, or if you plot the points, then in all likelihood, you only have to find the slope between 2. Okay, so just looking at their drawing after they plotted the coordinates, they want us to prove that this is a right triangle. Okay, so a right triangle has 1 right angle. We can see that this is definitely not the right angle, and this is probably not the right angle either. So the only one that potentially has the right angle is right here. All right. So I'm just drawing this in for now. I don't know if it's a right angle. That little box indicates it's a right angle. But anyhow, we want to find the slope of this line right here. I'll call that M1, and we want to find the slope of this line right here. I'll call that M2. All right. So this point over here, I'll do it in a different color. This point right here is -1, 2. This point right here is 5, 0. And this point right here is 4 on the X and -3 on the Y. All right, so now we only have to do the slope twice. And we don't need the slope of this line here. If we hadn't drawn it, then yeah, we would probably have to do that. All right, so for M1, and in generally speaking, we know that slope, let me erase this here, make a little room. We know that slope is y2 minus y1 over x2 minus x1. So for M1, do it in a different color here. For M1, subtracting the y's, you want to go in the same direction. I'm going to do 2 minus 0. And since I started here with the y, I start here with the x. -1 minus 5. Okay, 2 minus 0 is 2. -1 minus 5 is -6. And reducing that fraction, that's -1/3. And now all we have to do is check M2. So M2, change in y, I'm going to do 0 minus -3. Change in x, I'm going to do 5 minus 4. Notice I started with this point for both subtractions, okay? You have to start with the same point for both the x and the y. 2 negatives is positive, 0 plus 3 is 3, and 5 minus 4 is 1, and 3 over 1 is just 3. So it looks like they are perpendicular, I can tell already. But just in case, the 2 steps to finding if the slope is perpendicular, you want to flip it, and you want to change the plus minus. 2 steps, okay? So -1/3, flip it. That's going to be -3 over 1. Change the plus minus sign. It's negative now. It's going to be positive. So 3 over 1 is just 3. Does that equal the other slope? Yes. So these are perpendicular. I'll just abbreviate. They're perpendicular. All right, so perpendicular lines, they make a right angle with each other. So that proves it's a right triangle. Okay, the answer is yes, it's a right triangle. Remember, a right angle is 90 degrees. A right triangle has 1 right angle. And perpendicular lines make right angles. make a right angle. So that's it. All right, next example, show that these 4 coordinates are the vertices of a parallelogram. Okay, recall from geometry the definition of a parallelogram. It has opposite sides parallel. So I'm just going to write opposite sides parallel. Actually, I'll just draw 2 lines indicating that they're parallel. So we have 4 coordinates here. Do you need to draw the parallelogram on the graph? Well, it depends. If they give you the points in order, going counterclockwise or clockwise, then you're okay. However, if the order of the coordinates are mixed, you're going to have to draw the parallelogram. You're going to have to graph it. And the reason is because you don't want to find the slope of the diagonals, okay? You don't want to find the slope from here to here and here to here. All right, that's useless. So we need to find the slopes of the sides. All right, and we have to make sure that we're doing that. All right, so just looking at it, negative 3, 1 is this point right here, negative 3, 1, so I'll call that point A. 3, negative 5, let me see, 3, negative 5 is this point here, I'll call that B. And 4, negative 1 is this one here. And negative 2, 5, I'll call that point D. That's that right there. Okay, so they did list the points in order. Okay, so you can certainly look at the graph if you want. But if they listed the points in order, then you're okay and you don't even need the graph. Okay, so as always, we are using our slope formula. y2 minus y1. x2 minus x1. Okay, it's a little bit of tedious work here, but it's not too bad. All right, so for the first one, we'll just call it slope 1. Change in y, I'm going to do 1 minus negative 5. Change in x, negative 3 minus 3. 2 negatives make it positive. 5 plus 1 is 6. Negative 3 minus 3 is negative 6. And that slope is negative 1. Let's move on to the next pair, M2. All right. So I'll do negative 5 minus negative 1 for the y's. And I'll do 3 minus 4 for the x. 2 negatives make it positive. Negative 5 plus 1 is negative 4. 3 minus 4 is negative 1, and that slope is 4. Okay, so I hope the other ones match. Let's see, we have M3. Because remember, parallel lines have the same slope. Change in y, negative 1. I'll go the other way this time, just to prove that it doesn't matter. 5 minus negative 1. And I did the y going that way, so I have to do the x going that way. Negative 2 minus 4. 2 negatives make it positive. 5 plus 1 is 6. Negative 2 minus 4 is negative 6. And that equals negative 1. So far, so good. We have negative 1 matches negative 1. Finally, the last one. Because remember, you need opposite sides parallel. So we're going to need 2 pairs of slopes that are parallel. All right, last one. We're going to do last point to first point. Change in y is going to be 5 minus 1. Change in x is going to be negative 2 minus negative 3. Whoops. 5 minus 1 is 4. 2 negatives make it positive, and negative 2 plus 3 is 1. 4 over 1 is just 4. Does that match? Yes. Okay, the negative 1s match. And the 4 and the 4 match. So we have two pairs of equal slopes. All right, and that proves opposite sides are parallel. That's how you prove something is a parallelogram. Opposite sides are parallel. All right, so there are the four slopes. A little bit of tedious work, but that's how you would do it. There are many applications of linear equations to business and science. Suppose the property tax rate for a school district is $1.50 per $100 valuation. This is a linear relationship between the value of the property and the amount of tax on the property. The slope of the line in this relationship is tax change divided by value change. So that's $1.50 divided by 100. As the value of property increases by 100, the tax increases by $1.50. Two variables are linearly related if a fixed increase of one variable causes a fixed increase or decrease in the other. These changes are proportional. For example, if a property increases in value by 50, then its tax would increase by 75 cents, right? Because half of 100 is 50 and half of $1.50 is 75 cents. All right, so they said this is basically slope. So this numerator would be the change in y, and the denominator would be the change in x. So, of course, the y variable is the tax change, and the x variable is the value change. We're going to do some examples. So when you write your line equation, y equals mx plus b, you are basically writing y in terms of x. All right, so typically you plug in a value for x and you obtain a value for y. All right, so the bottom line is, since y is based on x, y is the dependent variable because y is dependent on x. All right, y is dependent. That's the dependent variable because you plug in a value for x and you obtain or get a value for y. So since y is dependent on x, x is the independent variable. All right, so that's typically how a linear or line equation works. Y is the dependent variable and x is the independent variable. Okay, first example, a family paid $52.50 for water in January when they used 15,000 gallons, and they paid $77.50 when they used 25,000 gallons. Find an equation that gives the amount of the water bill in terms of the number of gallons of water used. Okay, so we said before, y in terms of x, right? All right. So we want an equation that gives the amount of the water bill. So y is basically the water bill in dollars. And they want it in terms of the number of gallons of water used. So the number of gallons of water is going to be your x. Okay? And that makes sense anyway. We said before that X is independent and Y is dependent. And obviously, if you have a water bill, the water bill is dependent on the number of gallons of water used. I'll just write number of gallons of water. So obviously the water bill is going to be the Y and the number of gallons of water is going to be X. All right, so even if they hadn't written this last sentence, you would know which one is X and Y. All right, so let's see. Let's write a little chart for the X and Y. All right. It's the dollars or the amount is the Y. So 5250 is associated with 15,000 gallons. Okay, so the dollar amount is 5250. And that's associated with 15,000 gallons. And the other monetary amount, $77.50 for 25,000 gallons. Okay, $77.50 for 25,000. All right, we want an equation y equals mx plus b. You can do point slope first if you want, and then convert it. I'll do it the other way for now, since we've been doing a lot of point slope. I'll do it the other way. Let's find the slope m. Okay, we know that's just change in y over change in x. So subtract going the same way. I'd rather keep it positive, so I'm going to do 7750 minus 5250. And in the denominator, I'll do 25,000 minus 15,000. Notice I went the same way. I subtracted in the same direction on both of those. Okay, and using the calculator, I get 0.00025. Okay, you certainly could leave it as a fraction if you want, but we're going to be writing an equation. Okay, this is actually 1 over 400. So you could use either one. I'm going to use the decimal for now. All right, that's the slope, m. And now what you have to do is you have to plug in the slope and a point and solve for b. Okay, so let's see, either of these are fine. I'd rather work with the smaller number. So for the y, I'm going to use 5250 for the y. For the m, I'm going to use 1 over 400. Actually, I'll use 0.0025. For the x, you have to choose the x that's associated with the y that you use. You can't mix and match coordinates. So this y is with this x. So that's going to be times 15,000. And let me erase this. I need the room. All right, so I just added the plus b on the end. And this mess right here, 0.0025 times 15,000. That's going to be 37.5. And this is 52.5. And this is plus b on the end. Okay, solving for b, I'm just going to subtract 37.5 from both sides. And it cancels here. And I'm out of room here, but 0.5 minus 0.5 is 0.52 minus 37 is 15. So basically, b equals 15. All right, and now we can write the equation, or we can finish the equation for the y equals mx plus b. Y equals m, which is 0.0025, times x plus b, which is 15. Now, like I said, you can use point slope and then distribute instead of solving for b. You can do it that way as well. All right, example 2. A bakery sells a special bread. It costs $6,000 to produce 10,000 loaves of bread per day and $5,900 to produce 9,500 loaves. Find an equation that gives the daily cost in terms of the number of loaves of bread. Now, we said before y in terms of x. So the daily cost y is going to be in terms of x. All right, so I'll do it in a different color here. The daily cost is going to be your y, and the number of loaves is going to be your x. All right, so let's do the xy chart real quick. All right, so we have the x and the y. You only need two pairs of coordinates because 2 points make a line. You can make a line with 2 points. Cost is y, so 6,000 goes in the y column. $6,000 is 10,000 loaves of bread. And again, cost is y, so 5,900, 5,900. And that gives you 9,500 loaves of bread. Okay, once again, we have our 2 points, and we can easily make a line. This time, I'm going to do the point slope form. All right, so I'm going to use y minus y1 equals m times x minus x1. Okay, if you like the other method, you can certainly use it. But I like this one better because I like to distribute. Anyhow, obviously, we need slope just like last time. So let's do the slope calculation. Okay, the slope is change in y over change in x. Change in y, you can subtract either way. I try to subtract and keep it positive. So I like to subtract the smaller number, but it doesn't matter. 6,000 minus 5,900. All right, and the change in x, you want to subtract going in the same direction. 10,000 minus 9,500. All right, so you can use a calculator. I can do this manually. Numerator, subtract, that's 100. Denominator, subtract, that's 500. Okay, and that's just 1/5. Or you can use 0.2. Either one works. All right, and now for the point slope form, we have to plug in a point, right? We have to plug in a point for x1 and y1. We can choose either one. All right, so let's do that. Y minus y1. This row looks better because this one has the 900 and the 500. This has 6,000. I like that better. And that equals m, which is 0.2 or 1/5. Either one works. And this is going to be x minus. Okay, since we chose this y, we have to choose the same respective x. So 10,000. And now we don't have to solve for b. We can just distribute, and we can add. So this is what we're solving for y. This is minus 6,000. I'm going to do plus 6,000 on both sides. Cancels here. All right, and we're left with y equals distributing 1/5 times x, And 1/5 times negative 10,000. Well, let's see. Negative 10 divided by 5 is negative 2. So this is going to be negative 2,000. And then plus 6,000. All right. So that's it. Negative 2,000 plus 6,000 is 4,000. So just rewriting here. Y equals 1/5 x, or you can say 0.2x. Negative 2 plus 6 is positive 4. All right, so that's it. Either method works. Example 3, the dosage of medication given to an adult cow is 500 milligrams plus 9 milligrams per pound. Find an equation that gives the amount of medication per pound of body weight. Okay, so the amount of medication is dependent on weight, right? So since medication is the dependent variable, okay, the medication is going to be your Y, and the weight is going to be your X. All right, so let's make a little XY chart here. All right, it says the medication given to an adult cow is 500 plus 9 per pound. Okay, so that means at 0 pounds, it's going to be 500. And it's 500 plus 9 per pound. So at 1 pound, that's 500 plus 9. At 2 pounds, it's going to be 500 plus 9 times 2, and so on, right? But we only need 2 points. Okay, so I'll just use 0 and 1. 500 plus 9 is going to give us 509. All right, so we can easily find the slope. We know that the slope is change in y over change in x. And the change in y is going to be 509 minus 500. Change in x go the same way and subtract 1 minus 0. Okay, so 509 minus 500 is just 9. 1 minus 0 is just 1. You can put 9 over 1 if you want, but that's just 9, of course. I'll write it down here since I ran out of room. All right. Now, did we need to really do that? No, because it says in the problem that it starts at 500 and it goes up 9 milligrams per pound. So we didn't really even need to do that. Okay, the slope was basically given in the problem. And we know that B is the y-intercept, right? But the y-intercept of a graph, if you have a graph, remember the y-intercept is where it crosses the y-axis. And that is where x equals 0. But we have that value already. At x equals 0, y is 500. So the value for B is 500. Now, once you have m and b, that's it. You can write your equation for y equals mx plus b. So there wasn't much to do there, really. Y equals the slope m, which is 9, times x plus b, which is 500. That's it. All right, next example. At the surface of the ocean, A certain object has 1,500 pounds of pressure. For every foot below the surface, the pressure on the object increases by about 43 pounds. Find an equation that gives the pressure in pounds on the object in terms of its depth in feet. Okay, so the pressure in pounds is going to be your Y, of course. And that is going to be in terms of its depth. So that's going to be your X. As always, let's make the XY. Actually, sometimes you might not even need this, but I'm just showing you. Let's make the XY coordinates. All right, so every foot below the surface. So let's see. At the surface, that's going to be 0 feet. And that's 1,500 pounds of pressure. Okay, so X is feet, and at the surface, it's 0 feet. And that's 1,500 pounds of pressure. All right, and every time you go a foot down, the pressure increases by 43. And remember, the depth is in feet. So if you go down 1 foot, the pressure increases by 43. So it's going to be 1,500 plus 43. So do we need to do slope? No, we do not. Okay? I mean, you need to know the slope, but there's nothing to calculate. The slope, M, I'll just say slope equals, they said they added 43 for every foot. Okay, so if this was 2 feet, this would be 1,500 plus 43 times 2. And it just keeps going up by 43 each time. So every time X goes up by 1, the pressure goes up by 43. So the change in Y is 43 over 1, which is just 43. All right, the slope is the letter M. And the y-intercept is the Y value when X equals 0. That's 1,500. That's the value for B. So just like the last problem, there's nothing really to calculate. You can just write your line equation for Y equals mx plus b. All right, so this Y equals, the slope M is 43, and the value for B is 1,500. That's it. All right, last one. A pancake mix requires 3/4 cup of water for each cup of mix. Find an equation that gives the amount of water in terms of the amount of pancake mix. Okay, so water needed is going to be the Y value, and it's in terms of X, so the amount of pancake mix is going to be your X. All right, let's set it up here, X and Y. All right, so the water needed is Y, so 3/4 cups of water is going to be my Y. Okay, so I'll just write 3/4, and that's for each cup of mix. So for 1 cup, it's going to be 3/4. For 2 cups, it's going to be 3/4 times 2. And so on. Well, before we go anywhere, how about 0 cups? If we're going to make 0 cups of cake mix, how much water do we need? 0 cups of water, right? So that's pretty simple, actually. Sometimes you just have to interpret these things. All right, so the slope, how much does it increase by each time? This is 3/4 times 1, 3/4 times 2. If you had a 3, it would be 3/4 times 3. So obviously, it goes up by 3/4 each time. That's the value for m. And what's the y-intercept when the y value when x equals 0? So the y-intercept is just 0. That's the value of b. So it's actually pretty simple, the equation y equals mx plus b. All right, b is just 0. So it's going to be y equals m, which is 3/4, times x. That's it. Think about it. If the water is y and it goes up by 3/4 each time, that's your slope, 3/4. So that's it.